Well, here are the answers to problem set 3. The second question, you have to change the kilometer per hour into meter per second. Final velocity is 0 times 8 seconds, and you could find the acceleration using that equation. Obviously it's going to be negative because it's slowing down. And then you can calculate the net force just by multiplying that with the mass. And number 3, Ft is the tension acting up, the weight of the fish is acting down. For the net force is Ft minus mg, which is equal to ma. Generally, by Newton's second law, the net force is equal to m times a. Just rearrange. Make mass the subject. Get 22 by 9.8 plus 2.5, which gives 1.79 kilograms as the mass of the fish. Number 4, you're asked to find the force on the ball by the glove, which is exactly equal and opposite to the force on the glove by the ball. So we find the force on the ball, for which you need to find the acceleration of the ball from the initial velocity, the final, and the displacement. Use this equation. Make acceleration the subject. Get negative 5568 meter per second squared. And then multiply that with the mass of the ball to find the force. The negative force shows that it's an opposing force. Now that is the force on the ball. Therefore the force on the glove by the ball is the opposite of that, which is 780 newtons. Number 5, jumps from a height of 3.9 meter. Initial velocity is 0. You're asked to find the final velocity. Use that equation. And then in the second case, the initial velocity is 8.7 and the final is 0. Displacement is 0.70 meter. Find the acceleration using the same equation. It's negative 54. So find the net force by multiplying the mass Actually, the weight should be considered because you have the weight acting down, the normal reaction acting up, which should be equal to MA. So rearrange to find the normal reaction. Get 2700 newtons. Question 6. There are two buckets, both of the same mass. First the free body diagram for the lower bucket, and then for the upper one. That's on the lower bucket, 31 newtons. And on the upper one, there are three forces. And therefore the tension is double that on the lower one. In the B part, it has an acceleration upwards, and so therefore the tension is going to be even bigger because you're pulling it against gravity. And then the tension on the upper one. In this case, the force applied at 45 degrees, Fp, has to be resolved into two components. And the components are going to be Fp cos theta, which is Fp cos 45, and Fp sine 45, as shown in the diagram. So when you take all the forces along the x-axis, you get Fp cos 45 minus friction equal to 0 because it's not moving, or it's moving at constant speed. In either case, there's no acceleration. Therefore, friction is simply 62.2 newtons. Now, taking the forces along the y-axis, you have Fn up and the other two down. So minus mg minus Fp sine 45 is equal to 0. And on rearranging, and substituting the numbers, you get 199 newtons. In the last part, the initial velocity is 0, the final is 1.5. Time is given as 2.5 seconds, so we can find the acceleration using this formula. Gives 0.6 meter per second squared, and therefore the net force along the x must be Fp cos 45 minus friction. This time is equal to m times a. And therefore the force of the push must be sum of the two divided by cos 45. .9 newtons. Number 8, the sprinter is pushing against the starting block at 22 degrees with a force of 720 newtons. Resolve that into the two components. Take the force along the x-axis. There's only 720 cos 22, which should be equal to mass times acceleration. So rearrange to find the acceleration. As 10 meters per second squared. In B, time is given, the initial velocity is 0, the final velocity is what you got to find, and A is 10 meters per second squared. Use this formula. But it was 10.27, so 10.27 times 0.32 gives you 3.286 meters per second. In question 9, the string makes an angle theta. Force along the string is Ft, which is resolved into Ft cos and Ft sine, and the weight is mg. We have to find the final velocity, for which you have to get the acceleration. That's the formula for acceleration. Well, the final velocity is given as 28, and so you can get the acceleration. And taking the forces along the y-axis, you have Ft cos theta minus mg is equal to 0. And rearrange to get Ft as mg by cos theta. Along the x-axis, you only have one force, which is Ft sine theta. So that should be equal to m acceleration along the x. And that's mg tan theta. Therefore, acceleration along the x-axis is, well, the masses get cancelled out. This it's cancelled out, and so tan theta is ax by g. On taking the inverse of that, you get (25 degrees). Number 10. The weight of the car acts down, mg. Normal reaction is Fn, and friction is against the motion. And so friction is upwards because the car is trying to slide down. And the weight is resolved into two components. You can see mg sine theta and mg cos theta are the components. And so taking the forces along the y-axis, you have Fn minus mg cos theta should be equal to 0. Well, you got to have equal to 0 there. Anyway, so there Fn is mg cos theta. And then taking the forces along the x-axis, you have mg sine theta acting down, friction opposite, so minus friction is equal to 0. But again, friction is mu times the normal reaction, but here the normal reaction is mg cos theta, substituting. So rearrange that equation to find mu s. Tan inverse of 0.8, which gives 39 degrees. So that's the maximum angle. 11. Weight mg resolved again into mg cos and mg sine. Normal reaction Fn, and friction is opposite to the motion. That's the x and the y axis. So as before, take the forces along the x-axis, mg sine theta minus friction equal to mass times acceleration. Along the y, mg cos theta minus Fn is equal to 0 because there's no acceleration along the y-axis, from which Fn is mg cos theta. And again, friction is mu times Fn, and so it will be mu times mg cos theta. Mu is force of friction divided by mg cos theta. Get the force of friction as 73.4 newtons. Take that number and substitute it here. You get 0.58. Question 12. Change it into meter per second. Find the acceleration. Gives 1.85 meter per second squared. Well, I just forgot to draw the diagram. I'll do that later. But it's the same concepts. This time you're pushing, therefore you have an additional force, which is Fp here. That's the force of the push. Rearrange to find it, and then you know that Fn is mg cos theta. Mass is taken out because it's in all the terms. G could be taken out from those two. $39.6. Okay, that's the diagram now. Mg resolved into two components, normal reaction. 13. You have two boxes, 75 and 110 kilograms, and you're pushing on the 75 kilogram. Here actually the normal reaction is the sum of the two masses times g, and friction is going to be mu times that. So taking the force along the x-axis, you have the force of the push, which is 620 minus friction, is equal to mass times acceleration. So make A the subject. (1.9 meter per second squared). I didn't do the second part of that. Anyways, now 14. Being the same equations, except that it's on a horizontal surface, so it's easier. You know, the force of friction is the only force, so that should be equal to ma. That is what has been done there, and the masses get cancelled, and then you can find A as negative 7.4 meter per second squared. The last question. Again, the only force is the force of friction, so that's equal to minus mu Fn, which is minus mu mg. The masses are again cancelled here, so you get A is equal to minus A by g. Use the equation for acceleration. You get negative 3.57, and plug it back into that equation to find mu. As 0.36. Thank you.